Dear students, welcome to the knowledge series on direct memory access. The direct memory access is a model that exchanges the data between the memory and the input-output models. Because it will, with the help of a direct memory access, we can allow the CPU to do various other tasks so that just input-output transfer that instead of the CPU to handle, the direct memory access perform that particular task. So in the direct memory access, we are having there are certain blocks are available. So basically in the DMA or a direct memory access, the processor is having issues with respect to the large amount of input-output based instruction if it has to take place. So in that case, not to load the CPU, the DMA, which is an assistance to the CPU, perform this particular task of the input-output. So DMA module manages the data transfer between the main memory and the input-output devices with respect to the processor instructions or interventions. So the DMA model actually takes the control of the systems, thereby it performs the task. Now here, when we see the actual functions of this particular block of the DMA, there is a data memory is there, there is a data register is there, there is a control logic is the address registers are there. Now what exactly takes place is that whenever a data has to pass, this CPU will be having different registers like a general purpose registers, basically to store the temporary data, and there is a segment register is there that is to hold the program with respect to the data or codes, and this particular general purpose register it stores the address lines as well as the offset values. And there is another is the control register is the basically control register basically controls the interrupt, monitors the interrupt control and the addressing mode, how it has to take place, paging control, all these particular areas. And the instruction pointer register is there, that is to see that number of data count that is being carried out based on the instruction pointer will be incrementing at every instructions. So that is what we see in this particular area of the registers. So this data line and address lines is being handled under the case of a DMA, which was initially handled by the CPU, so that under this particular line control has been given to the DMA to carry out that access. And there is a control logic is the DMA request, DMA acknowledge, interrupt is the read and write. All this control logic is a part of this particular DMA. So there are 4 blocks has been put across. So based on this, let us see this particular flow block diagram. So in this particular flow diagram, we can see that CPU is being given over here. The DMA is shown here. Disk control is there. That is your drivers or the secondary memory, and the primary memory is shown over here. So the very first thing is that the CPU programs the DMA controller by setting its registers to know that what the transfer has to take place. So that is what exactly does what I have shown conveyed here, the various registers. So that is a CPU programs the DMA control to set the various registers. Now the DMA controller initiates the transfer by issuing a read request over the bus to the disk controller as per the register which has been programmed by the CPU. So once this particular request has been transferred to the secondary memory, the disk controller, what it does, it fetches the next word of the internal buffer and write to the memory. So that is what this is a buffer. So what is the buffer? We will talk about in the continuation of this discussion. So under the buffer, the particular disk controller will face the disk controller will face the next word from the buffer and from the internal buffer and write into the memory. Now, which memory? Main memory. So this one. So every time the buffer will be storing the certain data. That is what exactly does. Now, when the write is completed, then the disk controller, what is going to do? It will acknowledge back to the DMA. So that is what acknowledgement is, acknowledging it back. Now, once this acknowledgement is finished, what then the next is that the DMA, when the block of data has been transferred completely, DMA will interrupt to the CPU. So this is how the whole cycle is take place. The first cycle program, register program, then DMA request to the secondary memory, DMA controller takes the data from the buffer, put it to the main memory. When everything is completed, during this phase, this address bus and data bus is been in the functional stage, and after when everything is completed, then this is acknowledged. It will get immediately that acknowledgement is taking place from the controllers to DMA, and from here then the interrupt is given back to the CPU, stating that I have completed my task. Then the CPU will be ready for looking for the next set of activities. Now we go to the next area on the DMA device driver. So before we go to the device driver, actually what exactly is this particular device driver and why it is very necessary, that is very important for us to understand, because we all know that there are different type of device drivers are available. For example, like if you take about for the mouse, there is a device driver is there. For driving a particular printer, there is a device driver is there. So like that, several set of drivers are available in the computer systems. So in a computing a device driver or in a computer, the device driver is a computing program. That you have to understand, that device driver is actually a software program. So whatever devices you have been, the computer is going to use it, whether that system has to work as per the requirements of the computer, then the device driver need to communicate with respect to certain program. So based on that software, the device driver will be able to instruct the computer systems, and thereby the operating system will understand that yes, this particular device is need to incorporate it. So that's why the user mode and the kernel mode try to interact. Now if you try to see this device driver, there are different stages. If you go to the core of the device driver, this is a device driver, user driver, application. So this device driver is interacting with the operating system here. So below this one is a CPU. So the device driver is basically a kind of a software that is a software program that is to control a specific hardware attached to the computer. When you say attached to the computer, means whom? The CPU is the one. So device driver essentially for a computer to work properly. So or in a simplified terms, if I put the device driver, it's a bit of code of a program that allow the hardware such as say a sound card, video card, USB port, for a printer for a printer control, or for example, if you are using a modem for controlling a modem, for all these things, with the help of operating systems, and such device driver program can able to attach to can work along with the hardware. So the purpose you have understand. So in one word, a device driver, actually it is a file that will allow the computer to know what configurations and what specification the particular hardware device is going to operate along with the CPU. Now, device driver task is what? It accept the abstract request. So it will accept the request. Now the second is that it will check the input parameters. So that is what it is I'm talking about. The what is the input parameter is going to see. Then it transfer this abstract to concrete. So that means whatever is the input device is going to attach to the computer, whether that is compatible with the CPU hardware. Check if the device is in use, and if it is in an active state, issue command to the controller. So automatically it will give a command to the controller, and then it will block that controller and verify is there any error is there in that, and after that it will if there is any error, it will instruct to that in the form of a pop-up signal. If there is no error, then it will allow that device to functions based on the final flag or the final signal that is being conveying in the form of ready to function or ready to act, ready in the active stage. So these are the device driver activities. Now when you try to see the device driver, when you connect a device, say for example you are connecting a mouse, at that instant immediately you can see that device driver is going to verify that particular mouse is going to particular hardware is going to access the CPU resources. So that's why under that particular situations we can take it into consideration that if a interrupt is being take place, if a particular device is being when you are attaching to the systems. So here I have shown a copy from the user buffer p count. It is counting that buffer what are the number of data that is being there in the buffer, and that is enabling the interrupt. And what is suppose if it is a printer has to be attached, so the printer status is being checked if it is in the ready state. If it is in the ready state, then particular printer initial point is being verified until that entire data is being sent, and finally the printer data registers flag becomes 1 or based on the number of not 1 in the sense number of data that has been you are transferring based on the count values. And once this count value is incremented, the acknowledgement interrupt is taking place, and that's how the entire data has been transferred from the device that is based on the applications. So this is what actually take place in the interrupt driven input output. Now if you go further, you can see that device driver, there are various form of a device driver. It is being shown here. For example, a printer driver, camcorder driver, or a CD-ROM driver. So if you are putting a different hardware, so different hardware is there. And here is shown a kernel. If you have seen what is in by kernel, kernel is the central part of the operating system. So that is what we have discussed in the operating systems with respect to the kernel. And what is the user mode? That is the user needs to access what? If a user want to print, if a user want to connect this controller and to see that what are the data stored in the controller, or the user want to read that particular what is there in the CD-ROM. So that is what we can use that particular device driver to perform to see that okay, these are the data that has been stored in the device is being used to access through the drivers, and thereby the operating systems gives a instruction to the various hardware, and thereby the information reaches to the user. So these are nothing but a device driver. So in a one word, a device driver is a particular form of a software application that is designed to enable the interactions with the hardware device, and without the without the device driver, any hardware whichever is connected to the computer systems will not able to execute. Now if you see the device driver, what are the different job? It accepts the request of the device first, and it interacts this device with the controller. And what is the controller? Based on the operating systems guidelines, based on the kernel, that makes the decisions when and how that particular device has to accept based on the input-output instructions. And then this request is being executed. If this particular device driver is okay, then particular request is being accepted. So that is what been seen in the case of a device driver. Here I am showing another one form of information. If you try to see that this is a device driver with the operating systems means I am showing you in this particular case disk is there, printer driver is there, knowledge driver is there. So whether if this operating system is working without a device driver, so it appears like this. But if operating circuit is working with a device driver, and if it is in a proper order, your appearance is exactly shown. That means it is being well organized with respect to the operating system before any device connect. Otherwise, it is going in a randomized manner. That is what we are putting here is device independent of a input-output software. Now next comes the buffer. Now what exactly this buffer indicates? Buffer actually is a memory in a portion of a computer systems, and it's a temporary holding. It's a temporary holding of a data, so that data can be if a data want to send or if it has to receive from the external device, then this buffer will be the point where it will try to see that it will store the certain amount of a data, so that it will not be a situation or a particular situation that the CPU will be directly interacting with the user. Rather, it will make intermediate buffering systems to store, and then based on the operating system's requirement, first in first out, or any other form of scheduling mechanism, that particular buffer can able to discharge. So here if you see the statement, a buffer is a temporary holding of a data to transfer to another location is usually located in the RAM. The concept of the buffer is to prevent a data congestions. That means whole data, if it is being directly accessed by the CPU, there are chances. So here you are creating a job. Job is nothing but a collection of process. So here you will try to create a queue, and thereby based on the queue the data is being transferred. So here is the input device. You can see without buffering, input device is directly interacting with the user process. Now input device, output device is there. If it is an input operating system is there, so input is coming, and based on the buffer it will able to move. So the processor will not able to get congested with the bulk amount of the data. So that is what I shown. If a monitor is there, if data want to displace to the monitor, it will pass through the buffer slowly. If the buffer is full, then if you still want to send some data, it will not do until the buffer is will discharge, or it will pass that particular information one by one. So here there is another type of a buffer placement is there. You have a back buffer, you have a front buffer, so that you will be getting a boosting in this particular case, so that the data transfer or the it will be fast, and the monitor will not be getting congested because of the overload of the data. And there is another way is that double buffer or a circular buffer. Double buffer means you put the system will put a parallel buffer, so that if a data if a one data flow is there, parallelly you can make the other data to also flow based on the need. The monitor will able to make the particular decision of the data flow to accept. So the front buffer will decides among these two to organize in from the front buffer towards the monitor. So that is how the front buffer is taking place. Circular buffer is what you can you put the operating systems in a circular way and try to see that which buffer has to take place under the particular process. So that's how it will be having it will be holding for this is a condition just with respect to the loop instructions. So that is how the operating systems will decide based on if a particular amount of a buffer need to move to the user after predefined time, then the buffer will be holding it and that particular instant at that particular queue for a certain time. So the buffer has a many form of holding in the memory based on the operating system's instructions. So if you look across the buffer in the form of a buffer where the particular in the RAM how the particular buffer is going to do place, it is in the RAM, automatically the buffer will be placed, but basically the buffer is a temporary storage. It will not be there immediately. You move that particular the data is moved, then the next data will be in the queue forms. So that queuing of the buffer is a supporting for the under the case that of the when we go for a scheduling, when a large amount of a data comes, buffer will substantially makes the CPU not to get overloaded and to work in a smooth fashions. So this three areas that we cover so far is the this area on the DMA, on the driver, and on the buffer. So these three things is going to boost the CPU performance, thereby the overall utilizations of the computer can get improved.